Hello and welcome back to Compiler Programming. Today I thought we switch gears a bit and move away from all the assembly stuff that we were doing before and do something a bit more high level. And in particular, I want to start working on type checking. Before we do that though, I want to do a quick update. After yesterday's video, I wasn't really happy with all the weird math that we had to do to figure out correct offsets, and then I realized that if just inside of this reserve stack function I flip the sign here and then flip the sign in the function that deals with the arguments in fn args, then all the math becomes like super trivial, and it's actually literally just this, right? You just take an argument and multiply it by the size. Anyway, so continuing with today's stuff, we want to do type checking, and type checking is not very complicated, at least in the basic case, which is what we will be doing right now, where we only have kind of concrete types and we only check that those types match. So in a sense, all that you need to do is you need to walk over the descriptor and compare pairwise what is happening there, right? So let's add a function, and what we will say, you will say descriptor same type, or we can just call it maybe even same type without the descriptor prefix, and it will return us literally a bool. And we say same type takes descriptor A, or pointer to descriptor A, and a pointer to descriptor B. Okay. This is our header. We can move it a bit up. And now we are ready to start implementing. Before we do, we can make a dummy implementation and say bool same type is return true, right? This is not very exciting, but it will work for the beginning. We can take our tests and actually add a few tests that will check for us that this is correct. Okay, it should say, or it should say that the types are the same for integers of the same size, right? And we say check that value from, or actually we have this descriptor S32 is and let's try descriptor S32, right? So that should tell us if they are the same. Obviously the test passes because we just returned true for everything. So let's add another test that sort of tests the inverse of different sizes. And we say descriptor S64 is not the same type as descriptor S32. Now run the tests, and then they also say yes, but our test should actually do the same, and like so. Okay, so it fails, which is great. So let's implement the actual function. Before we do, we can also try something like should not say that. I can do a bit of TTT actually before we do that. So in our function, we can say that return a or descriptor byte size of a is the same as descriptor byte size of b, right? So that should tell us if we are correct. Oh, that is nice. Okay. Good. So now check failed. It still says that descriptor byte size of S64 and S32 are actually the same. And this is kind of interesting to me. Check not same type. This is very, very funky. Why does it say that? So S32 and S64. Well, let's do a bit of printf debugging. Why not? And see what we are getting. Right. Maybe I just didn't save the file, I guess. Yeah, maybe that was the issue, because it seems to actually work. Yeah. Okay, good. So that obviously works, but now we need to add another test. It should say that pointer and S64 are different types, because pointer is the same size as the 64-bit integer, but they should not be the same for the purposes of the type checking, right? I mean, would be maybe certain situations in where we want to either promote or demote pointer to be just an integer, but in general, we want to not be treated the same. Okay, and the 64 are different types. Okay, and here we say descriptor S64, and we say pointer to is called pointer to. I think I added a helper function for that somewhere, because it was a bit annoying to type it everywhere. It's called descriptor pointer to. Okay. Descriptor pointer to, well, let's say pointer to S64, right? Descriptor, I cannot spell descriptor. Let's run the tests. Tests fail, because now we are only checking for the same size, which obviously is not what we want. So we say now if a type is not the same thing as B type, then return false. Okay, let's check if that is correct. Okay, should say that pointer are different types. Do I have some kind of issue with recompiling? Maybe it's just the scroll. Yeah, it's just the scroll. I should probably get into a habit of doing something like this. Yeah, let's have it as a command, so it doesn't we don't confuse ourselves with what failed, what succeeded. Okay, so this is fine. But now we go into the territory of pointers, because the next thing that we want to say is that something like, I will use now C indentation and say that S64 pointer is not the same as what? As, for example, S32 pointer. And this is where we get into this recursive thing where our type will have to call itself. But let's see what it looks like. So we go into here and we say 32. And right now, if we run this, then I believe it will say that they are actually the same. But they are not, right? So it reports that they are the same because we are only checking for type, and the type is the same, it's a pointer. And then we are only checking for size, and the size of the pointer is, again, the same. So we are not actually checking what is happening inside. And in order to do checks, we basically need to start copy pasting this kind of stuff. And we can go one by one, actually. Well, let's just do this. Okay, we did this comparison. Now we are at the end of the switch. We want to have a default case, and default case, we just say return true, right? So if we check that the types don't match at the very top, if we didn't find a very specific comparison for the type, actually maybe we can do default of this thing. Yeah, that might be a reasonable default. That's fine. Which actually will work for void because they will both be 0. Okay, descriptor type, and we're interested in pointer. And for pointer, we need to go deeper. We need to say that it's gonna be return of same type of a, and I don't remember how we call it. It's called pointer2. So we say a pointer2 and b pointer2, right? This is what we want to have here. And this is not descriptor type, this is a type. It doesn't matter if we use a or b because we just check that they are the same. Okay, let's see if this worked better. Good. So now our tests are passing. We can now add a few more things. So if we look at the types of the stuff that we have here, we have a bunch of things here, right? So we have structs, we have arrays, and we have functions. And we can tackle them one by one. So let's start with maybe arrays. Okay, should say that S64 2 is not the same as S32 2. So basically arrays of different types should not be equal to each other. But then we also need to say that arrays of different length should not be equal to each other. Okay, now we need to have basically array or descriptor array of, which we don't have, I believe. So let's add it. And array of, and it will require also for us to say the size of it. Now it's time to maybe do a bit of alignment. so it is easier to read what we are doing. Let's copy that. Let's copy this here. And here we say 64, 10, and 2. Okay, obviously this will fail because it has no idea what the hell is descriptor array. That means we need to go over here. And actually it's not even defined in here, so I guess our descriptor pointer 2 is just somewhere in this file. Or maybe in here. Okay. This is fine. Descriptor pointer 2. And we say descriptor array of. And we need to have the size of the array, which is S64. I guess we will just do the same here. S64 length. So let's check what our array looks like. It just has a descriptor of item and length. And we say fixed array. So descriptor star result is this. This is good. And then pointer to pointer 2. So instead of it, it will be array. And here we say descriptor is descriptor and length is length, right? That seems pretty good. Descriptor is not a member of array thing, it's called item. Good. So let's check this out. And we can do test or cls and test. Okay. Interestingly enough, it already correctly compares these arrays because it uses our byte size. And if you look at the byte size calculation function, that function actually multiplies, so here it multiplies the amount of items by the size of the item. Actually, it probably is a good idea to normalize all of that and say that it's actually U32. It might cause a few issues, but nothing we can't fix. So in here, yeah, it's just strlen can technically does not return U32, but we can curse this. This is fine. Okay, so this is just a small detour for the cleanup over here, which we now can, I believe, do this and be a bit easier. Okay. But we still have one failing test, and that failing test is about the... Actually, this is kind of interesting. So I would expect the opposite to happen. That it will check that this is... yeah, okay. Actually, does it make sense? Doesn't it make sense? Let's recheck that the tests are actually have the right thing. So yeah, this is descriptor S64, that is 10 of them. Is this not the same as descriptor S64 of 2? And our code reports that they are actually the same. But if we look into here, it should have multiplied the sizes and said to us that they are not the same, right? So what is going on? what is going on. Okay, let's have an explicit case for arrays regardless, because it would be nice to not rely on these too much, on like this implementation detail of descriptor byte size. And we basically say that if not, so more or less the same stuff as we have here, but instead of pointer to, it will be item or array item. Then return false. So if arrays don't have the same item, then it's not the right thing. Otherwise, we say a length the same as b length, or b array. Okay. We can also just do this, right? You can say it should be the same type of item and it should be the same length. Let's run the tests right now. And we still don't have this one failing, which is very, very interesting. Well, or do we? Or I again, yeah, we do have this failing. Okay. So let's bring up the debugger and see what is going on. Here's our tests. Can run, and it will just tell us which test is failing. Or it won't. It is S10 is the same as this one, right? So we can just do here, say, or maybe it will be easier if we just get in the value.c and check here. So continue. We can say A and B, they are both pointers, and that is because I screwed up when I copy pasted. This is why you should be very, very careful when copy pasting. So when doing this copy paste descriptor array of, I copied the wrong type. It should be fixed size array. Good. So if we run the tests now, everything is fine. And this also explains, right, why these tests was correctly passing, because it was thinking it's pointer and they are the same location in memory, so it was doing the right thing. Good. So this is our fixed size array done. Let's save this state and continue with more tests. The next test is about structs, and this is, I will not create a lot of them because it will be super tedious to do it on the video, but I might add a bit more later. I should say that struct and here, like with structs, it's really interesting, right? Because you have essentially two options. You can have duck typing, which means that if two structs have the same field, then they are the same. Or you can have what is called, I think, nominal typing, where you, like, every struct, every unique name will have a unique type. And I'm not exactly sure which version I want to go for. Eventually, I probably want to have both implemented in this language. But for now, for structs, we will do literal pointer compare. So we just say that, okay, there should be exactly one descriptor for this particular struct, and if that descriptor doesn't match, then you're out of luck, even if they are the same. Should say that structs are different if their descriptors are different pointers. So the way we can test this is we need to get this struct builder thingy that we have, right? So that we don't have to create the struct manually. And we can have one that has a field that is S32, and we can have another one that is gonna have a field that is, for example, S64. So we can say descriptor A is struct builder, then we do the second one, and this is, now we don't need this, right? We just say we want a new one, and we say B. Actually, even though they have the same fields, they should still not say that they are the same. So first of all, we check that same type of AA passes, and then we say that it is not the same type of A and B, even though they have the same fields. If we will eventually want to have something like I said, like structural typing or duct typing, where we compare just the fields of the struct, then we will have to have a different type checking function, or extend this and have like a special case there where we like treat structs as something. But it's way off in the distance, so this is not what we're gonna do right now. Okay, let's run the tests. Actually, CLS and test. So now it doesn't consider them to be different types, because it just falls through to this case of byte size, and the byte size of them will be exactly the same because they have the same field, right? So that means that for descriptor type struct, we do the following. We literally say A is not B. And we will have to have a different mechanism to make sure that as we build up the program, we don't create extra descriptors that are just copies of the array. But this is a different topic. Let's run tests, or it should be like so. This is why we have the tests, and everything is fine. This is where we get to the final and the most funky one, but in a sense it's sort of more of the same, and this is functions. So we want to type check that the functions have the same signature essentially. And again, if we get, or more like when we get to generics or whatever you want to call this, where functions can accept types, then it would come into a different topic altogether, because the type checking will be more complicated. Or if we do things like trait system that you have in Rust, or type classes like you have in Haskell, all of that requires a bit more fiddling, but the basic case, which is what we have in C, and this is sort of one of the reasons I'm doing this video series and this development in C, is because it's really, really straightforward to implement majority of what C does, and it's also easy to map and explain like how does this correspond to that, rather than going into these abstractions that are sometimes really hard to understand and figure out what they actually do. So enough talking. Now we need to say that functions with the same signature have the same type, right? And how do we define signatures? We can actually probably make use of this thing, which conveniently has a couple of functions that have different signature. It does not support multiple arguments, so maybe I shouldn't. I don't know. Let's take this stuff. Okay, where was this? Let's get rid of the body, and now we'll need to have two functions. So function A, and it will get a single argument that is S32, and it will not return anything. So it's just arg. We should have a version of arg that doesn't actually do anything with them, because I have this check turned on for unused variables. So this is function A. Now we want function B, and function B is gonna, for example, take, let's do two cases, right? So let's have function B that is taking an S64. So it takes, so like so. Have A, B, and C, and all of them should sort of not match each other. And we say check. First of all, we need to check that like the same types will match, and for that I will actually need to create I guess we need more functions. And since this particular test says that functions with the same signature have the same type, this is what we will test here. Check same type A and B. Functions with different signatures have different type. And here we actually will need to have these three different ones. And these three different ones, they will not be the same. So here we have B and we have C. Oops, I said C. And A and B are not the same, and B and C are not the same, and A and C are also not the same. Let's check. We need to have arg0, arg1, arg0, arg1. And I guess it wouldn't hurt if we actually check their return type as well. So we say function D and return value from S32 0. Okay, this is actually should get the descriptor instead of just passing the value. Oops. Cannot convert from descriptor to descriptor. So I guess it's even like this. And now we need a bunch of these. So here we say A is not same as B. A is not the same as A is not same as C. And A is not the same as D. Now it compiles. Let's run, and we have one failure. So this test passes because all functions are essentially like, we consider them a function pointer, so pointer to particular location in memory, and as such they are all the same size, 8 bytes. So this is why this passes. And different signatures have different types. It doesn't pass because we are not actually doing anything with the functions. Now, actually with the functions, it's sort of interesting in the same way as structs are. So you still can have a choice. You can say that you will like you compare functions by descriptor pointers. So like even if they have the same signature, they are not the same functions. But this is less useful in real programming. So usually you would expect that if functions have the same signature, you can pass that function to another one. So function. And for the function, we will need to do some iteration, or basically we need to start like so and say if a function returns descriptor if not same type, so it should be like this, same type, then it's not the same thing. Now we also can do an even faster check that says if a function argument counts, I believe it's called. Where is our function definition? Yeah, it's argument count and argument list. So that's good. So if argument count is not the same as argument count, it's not the same as b function argument count, then this is also false. If they don't have the same return type, it's false, or we can, doesn't really matter in which order we are doing this. Returns, if the parent has type struct, so it's actually like this. I'm telling you that whole arrow dot thing has to be one of the most annoying parts of C and C++. Function returns, and of course, descriptor now is a pointer. Okay. So this checks the return type, this checks the argument count, and now we have a thing that will actually do the iteration. So what is the type of argument count? It's x64. That's really not necessary, but okay. 64i is 0, I is less than a function argument count plus I. And if not, a function argument list I, or we need to do check type, same type, sorry, same type of this and this. Oops. Return false. This has to be B. And we, of course, don't need this. Same type. Has type structs. And we also need to do descriptor. So that is like this, I guess. And now we need to add another ampersand. Sometimes these type definitions get quite gnarly, or these expressions, I should say. Anyhow, this is the thing, right? In a function, we just can look at, for example, this one as an example and compare. So the first thing we say, does it have the same return type? Okay, if it doesn't, then they're not the same functions. They don't have the same type. Then we check, do they have the same amount of arguments? Maybe there is another one with 2 arguments and they're not the same. And if we introduce default arguments, this is going to be quite interesting depending on how we use functions. But again, this is later. And now we go through all of the arguments and we just check them. Seems pretty straightforward. Let's see if our tests agree, and they do. So let's recheck on the types that we have. So we have void, it will be covered, integers, it will be covered, pointer is okay, this we did custom thing, this we did custom thing, and this we did custom thing. So with that, we have type checking for all the different types. Well, that's all good and well, but can we actually use it? And we have a bunch of comments that basically says this, right? Do type checking. So we want to compare only operands of the same type. So we say now assert same type of a descriptor actually, we probably will do this a lot with values. So what I'm just thinking that it might be helpful to have a proxy function that works on values, and you have same value types or same value type, and it just accepts a value instead of the descriptor. And we can have it here, right? And it's just a dummy wrapper to help us avoid a bunch of typing this same thing. And this returns same type, and we can actually explicitly mark this as inline and say same type of ampersand a descriptor ampersand b descriptor. Good. So we have same value type. Now we can just do same value type a b. Great. Let's see if we are using compare correctly. And it looks like we do. So that's good. we can remove the comment because now we check that they are the same type. We can also do some, I can actually leave this comment to check that types are comparable. But in a sense, it's sort of fine because if the types are like, we can always come up with a comparison function technically. It might not do exactly what you expect it to do, but it will do something. So this is okay as it is right now, but later on we want to figure out how we want to handle comparisons of different types. But this is a topic for another time. Let's look at where we also have different comments. So we have function return. Here we say that it should check that all return paths return the same type. This will require a bit more setup in the function builder because right now we are not distinguishing a lack of descriptor with how should I say? We don't have a distinction between void return and unknown return. And in order to fix this, we will need to have this distinction. So that's also another thing. But what I was looking for is this stuff. Yes. So here we can actually do this because we can check that they should be the same type. And we can also, once we did assert that they are the same type, we can add another assertion and say that one of them, doesn't matter which one, has to have an integer type. So a descriptor type, or like this, is descriptor type integer. Is it how it's done? Descriptor type integer. Yes. So this is what division does, right? We cannot divide, at least right now, we cannot divide non-integers. You will eventually be able to divide floats, but we are a bit far from floats right now, so this is a good assertion to have. Let's see if it works. Okay, that's great. We still have all the tests passed just to check that we are not we actually running the code that we are running. Yeah, okay, so the assertion fires. And in reality, most of these are already taken care of by the fact that we have assertions inside move value that check that the types of this, that the sizes at least are the same. So, but it's always nice to have more type checking. So the same thing goes for multiply, which I should probably do a small pass and normalize this whole X, Y, and B business. So they have the same thing. Okay. Assertion failed. Multiply same type. That's interesting. So let's look at line 131. Okay, that's the assertion itself. It's in after hello world. Let's just run it in debugger and see. Okay, so this is where it failed. Now I'm a bit confused. Are you saying that this stuff failed? So I agree with you around that. Oh. What? This is not where it failed. Ah, okay. Sorry. I just have I had a breakpoint there. So where it failed was when we tried to multiply the width by the height. And well, that sort of makes sense. They are different size, so we have to fix that. Okay, support structs. Yes. Let's see if that succeeds. Well, it did succeed. Okay, now everything is fine. Good. So see, having type checking is nice because previously we were kind of doing bullshit, even though it was sort of working, but you can never be sure that it is actually working. Multiply. Okay, let's continue. I think in plus and minus I use a and b. Yep. And plus and minus have the same situation. We check that they have the same type. And here I actually might have test failures. Actually, no. So that's good. Let's look at other stuff. Move value is interesting in a sense that I think that for now we will keep it on just checking the byte size because there are weird cases that it needs to support. I will add a to-do saying figure out more type checking. Maybe we'll split into two functions. One of them will be kind of a low-level move that just does this kind of logic, and the other one will be more high-level, like assign that has the logic of types actually have to be the same. I'm not sure. And here we already don't have anything. But at least now our arithmetic is checking the types, and we have a generic type checking that will fail for any of the types that we have right now, which is great. With that, I think that's all for today. If you stayed till here, then thank you very much, and hopefully see you next time.